Hello, physics enthusiasts. I'm approximately constant, and today, for my first YouTube video, I'll be solving a few questions from the International Physics Olympiad 2023. Without taking much of your time, let's begin. Here is the first question of the theoretical section of the International Physics Olympiad 2023. This question is about the motion of colloidal particles, or the so-called Brownian motion. Let's read the question together. We analyze the one-dimensional Brownian motion of a colloidal particle with mass m. The equation of motion for its velocity reads mv dot is equal to minus gamma v plus f external. Here gamma is the friction coefficient, f of t is the force due to random collision, and f external is external force. We are set to assume f external is equal to 0. All right, f external is equal to 0. The first question is as follows. Consider that the water molecule collides with the particle at t is equal to t naught, giving impulse I naught at f of t is equal to 0 and f of t is equal to 0 afterwards. If v of t is equal to 0 before the collision and v of t is equal to v naught e raised to the power t minus t0 by tau for t greater than t naught, determine v naught and tau using I0 and necessary parameters in equation 1. All right, so let's attempt the solution. Before attempting a solution, let's try to understand what the question is asking. So this question asks to find v0 and tau in terms of gamma, m, and I0. We are given the we are given the following. M is equal to this is the equation of motion. F external is 0, so we can ignore this term. We know that F delta t is equal to I, and I is given as I0 when t is equal to t0, 0 otherwise, and v of t is given as 0 when t is less than t0, and this expression otherwise. So let's use this information to plot f of t and v of t. So the plot of f of t looks something like this, where at t is equal to t0 for a short time, there is some force, and the area under this curve if is I0. The velocity time graph looks as follows. We are given that the velocity is 0 for t less than t0, and then it jumps to the value v0 at t0, and then it decays exponentially. We are supposed to find what this value t0 is and what this rate of decay is. So let's work on a solution. My strategy for solving this question is to integrate with respect to time on a small time interval t0 minus epsilon to t0 plus epsilon. So once we do that, we get this equation where mass is constant using fundamental theorem of calculus. Using fundamental of theorem of calculus, uh, we will get v of t from ti to tf uh, minus gamma will come outside the integral and we'll get this term, and f of t dt from ti to tf will just be the area of under the curve, which is equal to I naught. Uh, we know that ti is is time less than t0, so v of ti is equal to 0. So we get mv of t0 plus epsilon is equal to this integral plus I0. Now let us take this nice step where we take the limit epsilon goes to 0. When we take this limit, epsilon here goes to 0. The upper limit of this function and the lower limit of this function become equal to this to each other. So this integral is 0, and we are left with v of t0 is equal to I0. So we can write v0 is equal to I naught by m. Now let's try to get an expression for tau. For time greater than t0, we can write f of t is equal to 0. We have the equation m dv dt is equal to minus gamma v. We use the separation of variables to separate, to put functions of v on one side and functions of uh, t on one side. We get dv by v is equal to minus gamma by m dt. We integrate both sides. We have the integral of 1 by v dv and and 1 dt. The limit of this integration is v at time t0, which is v0, to v at time t, and the limits of this of the other side are t0 to time t. Um, the integral of the function 1 by v is log v, so we get this is equal to minus gamma by m t minus t0. Now we exponentiate both sides and get the expression v of t is equal to v naught e raised to the power minus gamma by m t by t0. So comparing this with what was given in the question, which was v is equal to v0 e raised to the power minus 1 by tau t minus t0, we get tau is equal to m by gamma. So, so we can write the final solution as V naught is equal V naught is equal to I naught by m, and tau is equal to m by gamma. I hope you had fun solving this question with me. Let us look at the next question. The next question says actually water molecules collide with particles one after another. Suppose the IF collision gives the impulse II at time ti. Determine V of t on the condition that t greater than 0 and V naught V0 is equal to 0. Also give the inequality satisfying the range of ti that needs to be considered for a given t. In the answer sheet, it is not necessary to specify this range in the expression for V of t. All right, we understand. So in this question, instead of just one impulse at time t0, we have an impulse I0 at time t0, I1 at time t1, I2 at time t2, and so on. Uh, so to attempt a solution of this question, the question asks, find an expression for V of t. And we are given I of t is II when t is equal to ti and 0 otherwise. So let us consider when time is uh, between the k minus 1 and kth collision. For example, the second and third collision, what happens? Time is in between tk and tk plus 1, and f of t is 0 when a collision is not taking place. So we have this equation. Similar to before, when we solve this equation, we get v of t is equal to uh, there's a small mistake here. V of t is equal to vtk e raised to the power gamma by m times this. Or we can call this as tau. Next, we consider a small time interval around pk minus 1 when the kth collision occurs, where we integrate with respect to time to get this equation. And similar to before, we solve this. This goes to zero. This expression goes to zero, and we are left with this expression. Now let us the answer for what time interval we have to choose is, if we think carefully, um, when n collisions take place, we must calculate the velocity first, starting from t0. We have to go from t0 to t1 to t2 to t3 up to tn, and then we can calculate velocity up to tn minus 1. So that's what I wrote. And velocity v of t can be written as, firstly, I0 by m, uh, 1 by minus 1 by tau t1 minus t0. This is the velocity from t0 to t1. Then this is the velocity from t1 to t2. Similarly, the velocity from t k minus 1 to tk is given by this expression. So finally, the expression for velocity is given as follows. I hope you all enjoyed my video. I hope to make more videos every day. Thank you.